Good morning, everyone, and welcome. I'm glad to see so many of you here today. My name is Dr. S.K. Singh, and I hold a PhD in this field. Today, I'll be talking about the importance of daily verification of analytical balances in QC laboratories. The focus will be on how we can ensure accuracy and consistency in our measurements. We'll cover the procedures involved, best practices, and why this daily check is critical for maintaining quality standards. So, let's get started and explore this important topic together. An analytical balance is an essential instrument in the laboratory, especially when it comes to measuring mass accurately. It's crucial for quality control and pharmaceutical analysis because precise measurements directly impact the reliability of our results. Since weighing forms the foundation of sample and standard preparation, the performance of the balance really influences the overall quality of our data. Calibration plays a vital role here. It involves comparing the balance's readings against certified reference weights, which are traceable to national or international standards. This process ensures that the measurements are accurate, helps us control measurement uncertainty, and verifies that the balance performs well across its entire operating range. It's important to remember that calibration isn't just a good practice. It's a mandatory requirement under regulations like GMP, GLP, USB, ISO IEC 17025, and WHO GMP. These standards recognize how critical analytical balances are for maintaining data integrity and product quality. Regular calibration isn't just about compliance. It's also about ensuring that our results are trustworthy. It keeps us audit-ready and guarantees that our measurements remain reliable over time. Let's talk about the operating range of a balance. This is essentially the span of masses where the instrument can give accurate and repeatable results. It starts at the smallest weight you want to measure, what we call the minimum weight, and goes up to its maximum capacity, like 200 grams in this example. When you're calibrating, it's important to demonstrate that the balance performs well throughout this entire range, not just at a single point. To do this effectively, you should choose reference weights that cover several key points. The minimum weight, a low point around 10% of the maximum, the mid-range around 50%, and the high or near maximum, close to 100%. Using these points helps us verify the linearity of the balance. That is, ensuring it responds proportionally across small and large weights. This way, we can be confident that the instrument is accurate no matter what size of mass we're measuring within its operating range. So, in essence, understanding and validating this full range is crucial for reliable measurements and overall calibration accuracy. Let's talk about determining the minimum weight, which is a crucial step in our process. When we're trying to find the optimal solution, one of the key concepts is to identify the smallest possible weight that still satisfies all the necessary constraints. This helps us set a baseline, so we know the lower limit of what is achievable. In practical terms, we're essentially asking, what is the least amount of weight that can still meet our requirements? By figuring this out, we can make more informed decisions about how to approach the problem efficiently. This step connects directly to the overall theme of optimization. By pinpointing the minimum weight, we're working towards the most efficient and effective solution. It's a foundational concept that guides us in avoiding unnecessary excess and focusing on what truly matters. Let's take a closer look at the current regulatory requirements outlined in USB 41 for balances. This section emphasizes the importance of accuracy and repeatability in weighing processes. It's crucial that balances are properly calibrated across their entire operating range to ensure reliable measurements. Calibration isn't just a one-time task. It needs to be performed regularly and over the full range of the balance to maintain confidence in the results. Traceability is another key point here. All standard weights used for calibration must be traceable to recognized standards like ISO or NIST, which ensures consistency and international acceptance of your measurements. Finally, the acceptable deviation is set at plus or minus 0.1% of the test weight value. This means that your balance's measurements should stay within this margin to be considered compliant. Overall, these requirements highlight the importance of precision, traceability, and consistency in weighing to meet regulatory standards and ensure high-quality results in your processes. When it comes to using weights for calibration and verification, it's essential to rely on certified weights that are traceable to national standards. For example, weights classified under OIML R111, such as F1 or F2 classes, or even better, are recommended for ensuring accuracy across analytical ranges. Now, looking at the specific weights, you'll see common values like 5 grams, 10 grams, 50 grams, 100 grams, and 200 grams. These are typical standards used for calibration, but the key is to select weights that match or exceed the required accuracy for your balance's range. Focusing on a 200-gram balance, for instance, the required standards include very precise weights such as a minimum of 0.02 grams, then 0.05 grams, 0.1 grams, 0.5 grams, 1 gram, and 2 grams. These smaller weights are crucial because they help verify the balance's precision at different points across its capacity. The main takeaway here is that using certified, traceable weights helps assure that your measurements are accurate and reliable. It's not just about having weights, but about having the right ones certified and suitable for your specific analytical range. This approach ultimately supports the integrity of your measurements and compliance with standards. All right, let's walk through the calibration procedure for the full range of the balance. First, it's essential to warm up the balance for at least 30 minutes. This warm-up helps ensure the instrument reaches a stable operating temperature, which is crucial for accurate measurements. Once warmed up, you need to level and stabilize the balance. Proper leveling prevents any tilt that could skew the readings and guarantees consistent results throughout the calibration. Next, you'll place each certified standard weight at the center of the pan. Center placement is key because it ensures the weight is fully supported and balanced correctly. After placing each weight, record the reading displayed by the balance. It's important to do this for all the weights in your calibration range. Once you have the readings, you'll compute the deviations between the displayed value and the known weight. Comparing these deviations against the allowable tolerance helps determine whether the balance is performing within acceptable limits. If the deviations are within tolerance, the balance is considered calibrated. If not, adjustments or maintenance may be necessary. Finally, document all the results thoroughly. Keeping detailed records of each calibration step and outcome is vital for quality assurance and traceability. Remember, a well-documented calibration not only confirms the accuracy of your instrument, but also supports compliance with quality standards. This process ensures the balance provides reliable measurements, which is the backbone of maintaining overall measurement integrity in our work. Now, let's take a closer look at accuracy validation per USB. This step is crucial because it ensures that our measurements are reliable and consistent with the standards set by the United States Pharmacopoeia. When we talk about validation, we're really focusing on confirming that our methods produce precise results that match the expected values. It's about building trust in our data, especially when it comes to regulatory compliance and quality assurance. By thoroughly validating accuracy, we're demonstrating that our processes meet the strict criteria outlined by USP guidelines. This not only helps us maintain high quality, but also supports our overall goal of delivering safe and effective products. So, in essence, accuracy validation per USB is a key pillar that underpins the integrity of our testing methods and the credibility of our results. Let's talk about minimum weight versus lower points. Even though when we start accuracy testing, weights are typically set at about 5% of the maximum capacity, so for a 200-gram balance, that's around 10 grams. We can actually go lower if the balance still performs reliably. Repeatability tests help us identify those lower limits, like the 0.3 grams shown here, where the balance's performance remains credible. For example, in this calculation, we see how we determine whether weights below that 5% threshold can still be used confidently. The key idea is that while the initial weight setting is a good starting point, we don't have to stick strictly to it. Instead, we evaluate the balance's repeatability at lower weights to ensure accuracy and reliability, especially when working with very small samples or measurements. This approach allows us to optimize our testing process by pushing the limits of what the balance can handle without compromising the quality of our results. It's all about understanding the balance's true capabilities and ensuring our measurements stay trustworthy, even at very low weights. Let's move on to the linearity check. Here, we're assessing whether the error varies proportionally across the entire range. To do this effectively, we should select at least 3 to 5 different weights, covering the minimum, low, mid, high, and maximum points. By doing this, we can see how the system responds at various levels. Next, we plot the observed weights against the nominal weights. This helps us confirm whether the performance remains linear throughout the range. If the points form a straight line, that's a good indication that our system's error is consistent and proportional across all weights. This step is crucial because it ensures our measurements are reliable, especially when dealing with different weight levels. It ties back to the overall goal of validating the accuracy and consistency of our weighing system. So, always remember to check for linearity to maintain confidence in your measurements. Let's talk about acceptance criteria. These are the specific conditions that a deliverable must meet to be considered complete and acceptable. They serve as clear guidelines for both the team and stakeholders, ensuring everyone is on the same page. By defining these criteria up front, we reduce misunderstandings and set realistic expectations. Most importantly, acceptance criteria help us verify that our work aligns with the project's goals and quality standards. They connect directly to the overall theme of delivering value and maintaining quality throughout the project. In essence, well-defined acceptance criteria are the foundation for successful project completion and stakeholder satisfaction. Now, let's talk about the reporting requirements for calibration records. It's essential that these records include specific details to ensure accuracy and traceability. First, we need to record the balance ID and serial number so we can precisely identify which instrument was calibrated. Next, documenting the test weights used, along with their classes, helps verify the calibration process and ensures we're using appropriate standards. We also need to include the observed results and any calculations performed during calibration. This transparency allows us to review the process and confirm everything was done correctly. Additionally, recording the tolerances and the decisions made based on those tolerances is crucial for compliance and quality assurance. And of course, traceability to standards must be documented. This traceability is what demonstrates that our calibration is audit-ready and meets regulatory requirements. Overall, these detailed records not only support compliance, but also reinforce our commitment to maintaining high calibration standards across all our equipment. Let's wrap up with some key takeaways. First, it's essential to calibrate across the full range, from the minimum to the maximum, to ensure our measurements are accurate throughout the entire spectrum. Next, we should always include repeatability and accuracy tests. These help us verify that our results are consistent and trustworthy. Using certified traceable weights is also crucial, as they provide a reliable standard for calibration and help maintain compliance with industry standards. Finally, never forget to document your tolerances and results thoroughly, because good documentation supports transparency and future reference. Keeping these points in mind will help us maintain precision and integrity in our calibration processes, tying everything together with the overall goal of quality and reliability. For further support, please feel free to contact us. We're here to help you with any questions or additional information you might need. Thank you so much for your time and attention today. Your engagement is truly appreciated, and we look forward to assisting you further.